Hi, I'm Andrew Armstrong and welcome to the Back Office Teardown Lab. I bought this the other day and it's rather good. It's a HDMI cable for Sega Dreamcast and it comes with a full HDMI wire, which is really nice. HDMI to HDMI, which is 5 foot long. And this is the box it came in, so you can have a quick look. I actually have it set up so that it does work in my lounge. I've been playing with it. It's really quite good. And it includes all the display modes, 480i, 480p, 576. So it basically acts as a VGA cable, which is nice. Something that is also curious about it is that it does have a USB power on the back, so I don't know what that's for, to give it a bit more juice. I haven't tried it, but something I have noticed when I use it is that the colours seem to be a bit washed out, and I suspect this is very much like the rather cheap but also good for the money thing I got for the Nintendo Wii, which was a port that cost about £5 that just goes into the standard Wii and gives you HDMI. So I'm not too worried about the quality for the price. I think it's fine on that. But because the picture was washed out, I just thought it would be curious to see if we can get into one, just to see if there's anything we can add, because we know it's coming from the VGA, which is effectively an RGB, for lack of a better comparison, and it means we might be able to attenuate the signal that's coming into it a little bit, and then that will look at that, see it's actually pushing in, and then that we can just tone it down a bit, because I think once it's just toned down a bit, I think it's going to work fine. I just think there's a slight level issue. Of course there's the obviously the possibility that we can't do anything, but we got to get in there first. So I'm just prying it with my nails. I've got it to a bit where it's just slightly open. I know I'm mumbling as well, by the way. It's 4 AM. It's very early. I do have that tendency to mumble when it's early in my videos. I've noticed that a lot. You've probably noticed it too. So let's get gently. So that's a nice anodized metal box, by the way. It is quite a good piece of kit. Look at that. Wow! Now we're talking. We can definitely do something with this. Look at this. So I'm going to be very ginger because I definitely do not want to break it. And look at that kit. We could probably actually read the chip off it if we needed to, but I don't think there's any point. So it's doing a lot. Let's be fair to this. It's doing an absolute lot. I'd be really interested to know if we get some of the other variants, like the one for the Nintendo Wii or something like that, and we actually just wire up to the inputs here, something standard like one of our Atari STs or something. Let's see what it does. This could be a pretty cheap Atari ST to HDMI converter, if these chipsets can be used in that way. I suspect they could. And look, there we go. We have an R. Look, it's really clearly labelled. Let me see if I can get this glue off so you can see exactly. It has all of the... Oh, it does come off. Gently. Be gentle. So they've done some hot snot on there, but that's fine. We're going to get this to work for us. Oh my word, this is a really good board. Look at that. Oh my gosh. 5 volts ground, horizontal, vertical, blue, green, red. Sorry, blue, green, red, which is this orange, and then we have a right and a left, so it has the audio too. Everything is here, and it's all being encoded in this chip into the standard HDMI signal. That is incredibly powerful to know. Oh my word. I know it might sound ridiculous to you guys at home how excited I am over this, but this is a very exciting discovery. And then look, there's a programming header on the back. I wonder, looking at the USB now, the USB doesn't have any data lines connected. It's only got power, so it's just getting additional power for the USB. I mean, it could be even feasible, but this thing could work a bit better if I just give it more power. I'm not sure if it's getting adequate power from the well, it's not actually. It's getting 5 volts and ground from the console itself, but it could potentially get power from the HDMI. It does say on it though, it does say actually, if you look at it, Wii It says WI, not WII, VGA to HDMI version 1.1. So that's really interesting. My gosh, what specs could this do really if it's within the specs of that? So anyway, enough gushing about how great this is. It's worth seeing now if any of these resistors can be attributed. I'm going to put my thing on continuity. See, my brain, I have to take me time to actually think about this. So which of these resistors can be attributed to attenuating any of these signals? So I'm looking at the blue. Let's take the blue, and it's going to a via. I'm saying via, and then it's coming. I think it's coming through these actually. These inductors. Hang on. So I'm going to hold it on the blue on the back potentially if I can. You got to bear with me on the camera, by the way, if you can't see it, because I'm not getting a signal, but I'm not trusting my probing. This is... Oh, there we go. So that's going through to this inductor and capacitor. So it's probably, to be honest with you, it's probably then coming back via a VR, and it's probably coming to one of these. So again, sorry, it's some edge-to-edge probing, but we'll get there. I'm going to probe this edge here. So that's a common. So it's more likely... Yeah, okay. More probing needed. So let's clear this. So we know it's coming in here, and then it's going via these inductors and capacitors. So I really need to have let me have a little think on how we can attenuate these signals a little bit and then fit something in. Because there's a voltage coming out on these, I need to check if it's within spec. So if it's coming out above 0.7 volts, then we got a problem here, and that's why it's overdriving that signal. What I'm going to do is I'm going to get my Dreamcast here. I'm going to knock it on. In fact, let's knock it on now. There we go. And I'm going to turn on the scope, which is going to howl. It's a noisy old scope. It's about 1 volt on average. I've got these things on the screen called cursors, and they basically let me pinch off what I'm trying to measure. So I've been having a think about this. We've got a 920 millivolts output, and we want a 700 millivolts output. So we need to build a potential divider like this. So that's what we have, and that's what we want. So we want to calculate the attenuation here, and you punch it into this calculation here, and you end up with a 2.32 value. And that will be in decibels. I didn't write that. Decibels. And you have to punch the numbers into these equations. So don't worry about that. That's for R1, R2. R1, R2 up here on your load. You end up with a 16 ohm and a 270 ohm resistors. That's what you need to put in the circuit. So you want to imagine that this is potentially ground, the ground wire, this one here, and then this would be like your red, okay? So you can intercept the wire coming in, put the resistor and let it go. There are potentially other loads in the circuit, but we don't really know them. So if you just add this, it should be okay, or you could just experiment with some inline resistors. Now the problem I have right now is that I don't have a 16 ohm or a 720 ohm resistor in any format, be it surface mount or otherwise, to try to shove into this. And you can see that you're going to need something relatively small if you want it to get into this case. So I might just experiment with some stuff off the shelf. I tell you what I'll do, rather than have the exact values we need, and I could lie to you because I'm probably not even going to show you the screen because I'm lazy that way, or I'll just shove in the values I've got and I'll tell you if it's got an effect. So I've got my resistor book. These look horribly high. These are from the 1K side here. So I'm going to take out these 1K surface mounts. And let's get this all organised, because the last thing we want to do is melt through our Dreamcast case. Although I'm not unplugging it from the Dreamcast, you'll notice, because I'm kind of a bit wary. This is was a broken, in inverted commas, Dreamcast, and I feel that the port on it is a bit loose. So that's the last thing I want to do. I wonder also, within the Dreamcast itself, you might actually have this adjustment, or potentially you might have adjusters in there. Please feel free to let me know down below if that's the case, because that could be cute. There is a VGA wire that you can get. I think I have one. And oh, crikey, there's our 3 surface mount. The VGA wire, and that basically seems okay. I tried that on a computer, so I don't know if the VGA cable has something in it. You could potentially fit something in on the connector end, you know, the part that goes into the Dreamcast. So it's hard to tell sometimes. It's like SCART cables. You never really know what's inside those. They normally have a bunch of resistors and stuff, don't they? So I've got my soldering iron here, just getting everything ready. Don't want to lose those little bits of dust off the table. Ah, he says. You can flick off a surface mount with very little effort, so just try to be a bit careful with them. They do look like dust there in the corner. So I'm just going to touch one of the first wires. I'm going to do the blue. Let's do the blue. Let's get that off. So remember, I'm just soldering these in line at present. We're not going to go for anything fancy to make a resistor divider, a potential divider. In fact, why don't I use this horrible helping hand I've got, like so. And if you've got one at home, that's how you're going to use one too. Precariously, I think, is the only word that describes those helping hands. And just only solder half the resistor. So I know it's hard to see, but look closely. I've just soldered it half on, half off. Now you've got to be a bit quick with this, because if you hold the soldering iron too long on the edge of that surface mount, it's likely to heat up the whole package and it's all going to go tonto on you. In fact, probably I'm just going to do the R, the G and the B in one go. I mean, you do have the horizontal and vertical, remember, as well, but let's just try to get away with the RGB for now. Okay, so that's ready. So how this was manifesting itself, when you actually looked in the screen, you were getting, basically, it looked like a chromatic aberration, which is odd for a inverted, you know, I'm going to use inverted commas, digital signal. We're not used to seeing that. So just that's what kind of gave me that suspicion that it's just overdriving it, and then the TV and everything's trying to, whoa, where did that go? Okay, we lost one. The TV's trying to overcompensate. Now 1K does sound a bit on the heavy side for this job. And if you're doing this at home, make sure you have plenty of resistors, because that one I had just scooted away out of existence. Let's have another go. I think I did have one more in the book. So these books are useful too. If you don't have one, go on eBay and type in surface mount resistor books, and you just get a big pack of them. And they've got like a couple, say 10 of each value. Just cut off a ribbon, and as you use them up, as you deplete them, just order some more. And then when you order more, because the individual components are so cheap, you can order like them in much bigger quantities if you know you're going to use up something. But it's just handy. I know it's not the exact values. I should get some smaller values. I do have some packs of standard resistors, through-hole ones, but as you can see from this, you probably, well, I suppose you probably could fit it with a bit of effort into the case. It was a roomy, quite a roomy case, really. Right, so we've got the R, the G, the B ready to go. just separating these wires out to give us a bit more room, because once we start, look, they're all twisted. Once we start, it's no good time to untwist them when we solder on the end. Remember, when you solder on the end of a surface mount as well, like a resistor, and it's not got the other pad on the PCB, it doesn't have any strength. You can rip off the end of that surface mount really easily. So let's tin up. So that's the resistors tinned up. Let's go for the blue because it's the furthest away and it'll be the hardest to get to afterwards. So it's up to you. You could trim that down. So that's the blue. That's the green. And that's the red. So clearly like that it's going to be super weak, but what I'm going to do is just nurse it over to my lounge and plug this in and see how it looks on the TV. And if that works, it's easy enough to just squirt a big load of epoxy resin on there and say job done. Right, shall I go test that? Off camera I was doing a lot of fettling, clearly you can see that, and I have determined all you need to do. It's simple. A value of resistor between, I'm guessing, 100 to 200 ohms or something might give you, we'll bring it down certainly into the range. So I've got a value here which is a 150R. I had my box of resistors. So this is 150 ohms, and I haven't even tried it, but I can tell looking at the scope that it's more or less in line. It's pretty much there with whatever loading's already on this circuit. So I'm just going to fit these, and of course they are through hole parts, so I'm going to have to cut it and fit it somehow like that. So that's going to be fun. I'll do the first one on camera so you can see how I go with it, and hopefully that'll be the end of it. You could put a tiny little potential device, I say potential device, I was going to say potentiometer, which is like a little variable resistor, and then that would let you adjust it as needed. So just again, let's try to get this. It's very weird. I'm holding the resistor in my left hand in a weird way to get to this board. It's a very awkward angle, I will say. So my idea is, you've got the blue wire that comes in. It needs to go here, so I could just cut this and bend it back on itself. Obviously I'd have to do that 3 times. It's going to be a lot more robust than the surface mount resistors when you're done. Can't zoom in anymore, I'm afraid, so you'll have to squint perhaps, but you can. I think you can see okay. And then we'll just put that on like there, just like that. Oh, there is a bit more zoom. So that's the blue. And again, he's trying to lift off. Don't lift off. I'm going to push that down. You can see why they put their hot glue on everything, can't you? So that's the one. I don't know, let's try, let's keep going, shall we? I was going to do it all offline so you wouldn't see my pain, but pain is to be shared among all of us, because now we can prepare these. We know how they need to be prepared. So we're going to chop off one end, I'm going to chop off the other. And you don't want these shorting out, of course, to the case when you're done, so we'll make sure they're protected with something. Dare I protect it with some hot snot? That could be an option. I can see that's definitely in the final variant of that. Once you're sure that's what we want to do and it's all working, we can protect it that way. But probably not a good idea to do it before then, because if we need to make any modification, we're going to be really stuffed. So now, because I've bent these resistors, they do have to go in a particular orientation, so I'm going to grab the little bit we've bent over on the top. I've got this dirty now. Right. So we're going to fit our green. soldering tip is so dirty. And then we're going to fit our red. Now the reason I'm struggling so much with these tweezers today is that I managed to break the tip of my tweezers, so I had to regrind them. You can see there. They don't have the little grabby hole. There's a little claw on the very nice surface mount tweezers that you can buy, which I had. And the little grabby claw has gone, and that really affects your grip. And I couldn't figure out yet how to grind a new one. I don't have a file small enough to grind myself a new one. Right, let's get the red in. The red is butting up to a surface mount component, so that's why it's being a little bit awkward. So the red is in. Okay, I'm just going to solder those other bits. Giving it a real world test now on the actual TV. It is better. I have to say it is better on the red and the green, but sorry, the blue and the green, but the red is still a bit bright. So I suspect we've used 3 similar values here for this, but we're going to need more tweakage. And I don't know what the tolerance of these resistors, but I would say if I was doing it ultimately, I would have to fit some really tiny twiddly pots into this to really get it right. So more experimentation needed. We're definitely a step in the right direction. If you've got one of these, feel free to experiment and let me know the results. I was just realizing something. This is effectively a VGA to HDMI, which is pretty much the same as an RGB, right, to HDMI. I think the specs, oh no, maybe not. The RGB has a different sync, right? Is it horizontal or vertical based on one or the other? So that kind of sucks. Anyway, a VGA to HDMI is relatively common though, isn't it? So that could be, again, for Dreamcast use. We probably have more options on these. Might have to look around for them. Anyway, have a go on yours if you've got one, and let me know how you get on. If you find some perfect values, ping me, and I'll put them down below in the comments. And I'll obviously put your name, shout out, and to your website, whatever you need. And yeah, we can share the goodness. Hey, sorry, just looking. I thought I had different value resistors there. No, but they are all 3 the same. I didn't cock up like that. As ever, thanks for watching.